Okay, in this section, we'll turn our design into a schematic. First thing is to should have already created the folder and the project. If you haven't, just right-click the Eagle folder in the directories and create a new project. Name it. Right-click that project. That folder, sorry, create a new project. Try to avoid calling it your name or anything like that. As I said before, you've got a lot of files and folders with your name in it, and we are going to be hunting through this stuff. Okay, next part is to right-click the project, create a new schematic. Now, remember, the schematic isn't a simulation, it's just a design area, so it's CAD. Most importantly, first is to change the units by clicking the top left button and turn all your units into millimeters. Okay, this button here that I'm pointing to is an add button. You're going to be using that a lot. This one is delete. You'll use that if you make mistakes, obviously. This one is to name your components, and this one is to add a value. So let's say you've got a resistor. You're going to name it resistor, so you remember that it's a resistor, and then you'll name it, give it a value. Now, obviously, this is for the shopping list, or the BOM, the bill of materials at the end. It's not the simulation, remember. That one was move, this one was rotate. These are the most important ones. Okay, so you've already got yourself the Adafruit library, so theoretically you can go to add components and you can search some components. Here I'm going to design a pocket torch with 3 LEDs, so it needs a battery. Now I know this is like a CR2302 or one of those coin cells, so I'm just going to select that, and I'm going to whiz through this. I'm going to add my LEDs, I'm going to add my resistor and my push to make switch. I'm rotating and I'm moving them around. This is only the schematic, so it doesn't really matter where you put things, but make sure you put them somewhere neatly and organized, because it will make your life a lot easier at the end. Okay, so the battery is going to come off and it's going to go through to the switch. The switch is then going to go to the LEDs in parallel, and then it's going to join to the resistor at the end in series and back to the battery. Again, these wires, it doesn't matter how these wires look, but I'm keeping it as neat as possible for my own sanity, so that I can read it and I understand what's going on. This is a very simple circuit. When you're doing your 555 circuits, it's going to be a lot more complex. Okay, I'm adding the values to my resistor here, so that when it prints out, I know that I'll need a 100 ohm resistor. You may need 10 resistors, all different. So this will actually create a bill of materials, and again, it's all about organization. Okay, here what I'm doing, on this button, I'm going to turn the schematic into an actual design. Okay, the black square with the white border is your PCB. It's a limited size because you're using the free version. Once you put the components onto the PCB, you can't take them off again because it's the free version. Okay, you can see that they're all held together with some sort of elastic band. Now, the elastic band is the connection. Okay, so if you imagine it like an elastic wire, this is going to help you organize where all the wires go. Okay, you can rotate these components, you can shift them around. I suggest for your the beginning, while you're getting used to it, give some space between the components. It will make your life a lot easier. Now I'm overlapping that coin cell battery because I know that the green circles are where I solder, but everything else is just a guideline. Okay, I'm moving it around. I've rotated so that I can untangle these wires. Of course, some of the wires you'll never be able to untangle. Now, what I'm going to demonstrate here is the auto trace, and I don't recommend the auto trace, but it's quite good to get you an idea of where the lines can and can't go. So here we're not going to use the top, we're only going to use the bottom. More low effort means it's not going to try, it will give you lots of vias, meaning you're going to have to solder wires and bridges and things. If you put more effort, it will take longer, and you'll see. It's a much better layout. Now these wires, these tracks are your tracks in your PCB, and remember that you can pass them through components. However, they're very, very thin, and very thin tracks are very difficult to solder. The easiest way to do it is to do it manually. So at the top you can see all the little lines. So we've got right angles, we've got angles at 60, 30, 45 degrees. Choose a thicker line. And now this track is looks very thick, but actually it's only 2.5 millimeters. That's a fantastic track to use. But the thicker your lines, the less space you have on your PCB, and if you look now, you'll see that these lines are touching. Funnily enough, this isn't actually a problem, but you don't want to get into that habit, because when it is a problem, it'll take you a long time to sort out. Okay, so what I've chosen here is just under 2 millimeters. I'm keeping the lines separate, and as you can see, as I put that track on, the rat lines disappear. That was the elastic bandy type lines, and it's just good for checking. Here I'm going to try and I'll screenshot these and put them on the OLP. These are just all the details you need. You're going to be choosing an EMC profile. That is, it's just a language that is used to talk to the machine itself. We're only generating the outlines and some drill holes. The drill holes are really useful if you can get those generated, because it means that when you drill, it will go into the center. Now you'll need to update your Java for this. If you haven't, it won't show you. Not a problem, but it's good for checking. And I think you'll have to notice that what you're seeing now is the mirror image. Remember, we're doing the bottom layer, so it's the mirror image, because you're going to have to turn it upside down. Now you're going to have to remember where you stored your project, and then go to that file that is etch.tat, open that, save this file to a thumb drive. It's actually quite useful if you delete those two top lines as well, the first two lines of it. Save it to a thumb drive, we're done.